This video is going to help explain material on the normal distribution, and it's going to supplement the material that's in the online text. A standard normal variable has a mean, mu, of 0 and a standard deviation of 1. The standard normal variable has a mean of 0 and a standard deviation of 1. It's a continuous variable. It's a symmetric variable. And here I attach to the email the standard normal variable tables, which you have here. As you can see, this is a standard normal variable. The mean right here in the middle is 0. You can see it's symmetric. The area in this piece is 0.5. The area of this piece is 0.5. And if we wanted to find the area between 0 and some number z, say 0 and 0.4, well, the answer is 0.1554. With 1554. If I wanted the area between 0 and 0.42, I would look up 0.4, and then here's a 2, and the column 2, and the area between 0 and 0.42 is this number right here. .1628. Again, this is the normal table for a mean of 0 and a standard deviation of 1, but suppose we don't have that. What do we do in that case? Well, let's see. Let's go back to our problem. There is not a problem because we can always make a z transformation. We can transform any z x into a normal variable by making the transformation z equal x minus mu over sigma. Let's give an example. Suppose the heights of people in a certain group have a mean of 65 inches and a standard deviation of 5 inches. 65 inches is 5'5", and standard deviation is 5 inches. And suppose I wanted to know what is the probability that someone is exactly 68 inches or 5'8". Well, since it's a continuous distribution, that probability is 0. Nobody is exactly 68 inches. Some people are 68.01, and some people are 68.0003, whatever. In a continuous distribution, there is no probability for any particular point. But we could answer the question, what is the probability that someone has a height between, say, 67 and 68 inches? That's our question. What is the probability someone is between 5'7" and 5'8"? Well, what we first have to do is we have to calculate the transformation using the formula z equal x minus mu over sigma. So the first z is 67 minus 65 over 5, which is 2 over 5, which is 0.4. The second z2 is 68 minus 65 over 5, which is 3 over 5, which is 0.6. And we want to find the area between 67 and 68. The way we're going to do that is we're going to calculate the area less than 68, the probability that someone is shorter than 68 inches. And from that, we're going to subtract the area, the probability that someone is less than 67 inches, and that's going to leave us with whatever is in the middle. So here we have probability z is less than z1, which is the probability that x is less than 67, which is the probability z is less than 0.04, and that's 0.6554. Now, how did I get that 0.6554? Well, from the table that I sent you. Let's go to this table. We want probability z is less than 0.4 is 6.5. Here it is, 6.554. That's the number. Okay. 0.07. We'll call that in also. And to get the area, somewhere between 67 and 68 inches, is we just subtract those two numbers. So let's go back to our problem here. So, probability that z is between less than 0.4 is 0.6554. Probability of z is less than z2 or less than 68 inches is 0.7257. And when we subtract the two, we get our answer. Probability that x is between 67 and 68 is the probability z is between 0.4 and 0.6, and that is 0.0703. If you like, you could also use the first table. This is the probability that z is between 0 and 0.6. This is the probability that z is between 0 and 0.4. And again, we subtract the two, we get the same answer.